Well, I've done a couple of things this morning and this afternoon. Let me turn on my light. There you go. You'll notice that the thrust washer is not behind the nut anymore. The nut is on a spacer. That spacer is a press fit to the inner race of the ball bearing, and the inner race of the spacer has been machined, drilled out to exactly the same size as this shaft. So it's a very snug fit, but a press fit into the ball bearing. Since it is a ball bearing, I'm not too nervous about the thrust, and I can say without the power on, it did rotate smoothly and there was no backlash. The important thing I wanted to show you was, if I can go to my jog controller, I'm just going to move this out a little bit, and if you recall, this end of the shaft was doing this kind of a thing when we were moving it last time, and I knew that wasn't right, so let's see what it does now. It's pretty stable. It's pretty solid. It's not moving. It's not rotating like it was. Okay. And I'm going to go back to my macros toolbox, and I'm going to do a return to zero. These are some macros that I'm learning that I already have programmed in here. Return to zero is my zero setting, and here you'll see a -5 off on the tool, or on the machine of zero. My zero is dead center. So when I say return to zero, it's going to come back to where it was in zero. And I want you to look at that. That rotation is quite good. And I've put a mark here for zero, and there's a mark. That's where zero is. And zero is halfway between everywhere kind of thing. That's the idea at any rate. So it seems like, what I did was I reprinted this part, and I made it, I checked all my dimensions and made it more accurate, or at least I think I did. Seemed to be more accurate. And then I pressed in the bearings, I put in the screws, I checked center, they all seem to line up really nice. And the only thing that's different is I don't have my thrust washer in here. There's just, they wouldn't fit over this spacer diameter, outside diameter, and I didn't want to do anything with it. I thought it's fine, it's a press fit, it's not going anywhere, it's a ball bearing, it's not going to be moving around. And it was a press fit in, so it's fine. And the nuts on that, so it's not gonna, if anything happens and it gets loose, it's only going to back out a tiny bit. But a ball bearing still has axial rotational thing, so it will still feel nice, and it does. Okay, so now the other thing I wanted to do was to go back to my jog controller, go out a little bit, and watch the motion of this guy here. It looks like it's drooping a little bit, you know. I can get down on it like that. It looks like it's drooping a little bit. I'm going to get out of ways, and then when I go to home, it'll home it in a hurry, and then you'll see more of the motion. Okay, here we go. Let's go to my macros, toolbox I mean, and return to zero. Now watch watch the motor. It's going to take off here in a second. There it goes. See it moving? It's moving a lot less, but it's still moving. And I'm thinking it's the coupler, but there's still, oh wow, look at that. What the hell's that? Whoa. All right, well, that's another thing to get into. Let's see what we have. Oh, that nut is loose. That screw is loose. Oh, that's not loose. That's not loose. Let's see where it's moving. Oh, it's down below. It's the lower. Okay. There's another rack on this side that I thought I adjusted. Maybe it's out of adjustment. I'm going to pull this all the way over, make that adjustment, and recheck this little wobble we have here. See what that's all about. The other thing I wanted to show you was the part is now designed. Oh, I don't know how to change this view for you guys. I just don't know. I don't know how, but what I've done is I've made the part that I want to take out reflect the shape that I have to mill out, except it's the width. I don't know how to explain this to you guys. I want that slot to end up looking like that. I want that slot. Now you see those bars? This bar here goes across, not this thing, ignore that, but this, sorry, ignore this, but this thing here goes across. So in this engine, as you'll see, okay, just imagine it, this is empty. That bar, here's the motor flange mount, okay, that lines up, all right, and this bar goes across just, sorry, this bar goes across just like this. I did it again. So the motor flanges are lined up, this bar comes across like this, and what I need to do is make that slot. So my first cut is going to be the top of this thin bar until I get down to this surface, and then it's going to increase in width and length, and I'm going to go down into that deeper bar. And I don't need to go all the way, I only need to go down to where that worm gear sticks out, so that my gear can hang down on top of that worm gear and engage with it. Engaging with that worm gear is how I'm going to get a rotation of a gear that will tell me the motor rotation and the position relative to the axle. That's how I'm going to get my puff and chuff signal. This is what this is all about. A puff and chuff, puff of smoke and a chuff of sound trigger for digital controls. It's all I'm doing here. It's crazy. But I need that slot in this chassis. You have lots of these chassis, but they were older and they don't have that slot. They never had this. They had the pinion that sticks in, but they didn't have the opening to get down into it. I'm milling that opening out in this guy, and I'm going to do that by, as you can see here, now I hope that makes sense. I don't know. Getting a little anxious here. I want to see how this thing makes that shape. There you can see I'm milling out that shape, and then as I get down to this level I start milling out this shape. I don't know if it makes sense, but that's what it's going to do, or at least that's what I think it's going to do. I think what I have done though is I've made it 38. The stock is 38, but my cut depth, target depth is 10, and I'm hoping that's still okay. I don't want to go too deep, but the other thing I was going to do was take off the wood and I have some foam over there. You can see that white foam sticking out. I'm thinking I might just try a couple layers of foam to see how it works, you know, if it crashes. Or maybe I'll just do an air cut, you know, take all that off and just do it in the air and see what it does. It won't come down to the end because I've told it, somewhere I told it. Here, stock is 38, so you can't go below that. You're gonna hit my table. And it's not 38, I only go down to 10 is the target depth. So what's happened is the plane is not this tabletop. The plane is 38 inches above the stock, 38 millimeters above the stock, meaning the material you're going to machine. So it thinks the plane is up here at 38. And when it homes in, it's bringing my Z down to within a few millimeters, you see. And it's there, it's offset. So it's going to move over. Let's look at this top down and see what we get. There. You see how this is weighed over. So what I want to do now is try to bring this closer. I would like to bring all of this almost to that. I want to bring all of this part geometry over to this guy. So it's closer to the center. This is the center. This is not in the center. So you see that. Okay, so what I can do is I have to grab probably one and then the other. I'm not sure. I'm not sure I can do this. Oh yeah, look. I just got to make sure that I maintain that offset. I don't know what that offset is, but I got to maintain it. Okay, so there. Now that. And then let's do a save. That should do it. Do a save. There, now look, I shrank my window, and now my piece is closer, and that's either the start or the stop. I don't know. But this would be the cuts to get the part out, and this is the cut to get the largest slot out. Oh boy, I don't know. I wish I could do this visualizer and make it work, but I don't know how yet. All right. Anyway, I'm going to fool around with this a little more and I'll get back to you, but I think I have fixed this piece and it's working real well. So now I'm going to see what I need to do here. This does not have that bushing and I only have one of those bushings, so I don't know if I can find another one. I just found it in a drawer of stuff. So, do I have two? I doubt it. But I'll see what I can do. I would like to get that little bit of thing out. I got to tune that. And this seems to have some droop, so I'm going to be trying. I may not do it today. I'm running out of time, but I wanted to add material in here and then a brace to come out and to lift this up so they screw together. I've been looking at some small block Chevy main caps just out of curiosity on another topic. But there was a... if you look at a cylinder block... Okay, it looks like this, and this is the block. And the crankshaft journal would slide down in here, and then there would be a cap on top, and the cap would look like this. And it would have the bearing half in here, and the screws would come down here, and then this cap would, the crankshaft would go in here, and this cap would come down. Now, there was an improvement in time where there was what was called a 4-bolt main cap, where this is just one bolt. This one had a bolt here and a bolt here. And then, of course, the block was then drilled to accept the 2 bolts, and that was stronger. But what they found was, because of this webbing out here was thin, but it got thicker back here, that was actually a weaker fix. So what people, machinists and stuff, came up with was a way to create what's called a splayed cap. So the cap would go like this, but the bolt hole drill was like this. So it came in sideways. So then they would extend this out a little more. They would drill a hole at an angle. So this bolt went in like this, and this bolt went in like this. And there was more meat back here for the bolt to bolt into and pull that down. And this splayed shape was stronger. So, yeah. So what I'm looking at, on the end of mine, I have this thing like this. There's this. There's the 2 screws that hold it together. And what I want to do is I want to come down with something like this. And this part sticks out. And my motor mount, just on the motor mount side, I don't have one here. Oh, I do. There's one. I see. Maybe I can use it. Yeah, I think I can use it. Okay. So the motor mount bolts like this, see? So I want this part here to stick out of this guy, jut up, and mate to this, and screw in 2 places. So if this is laying down, I want that part to come along, look like this, and I want one to go on an angle and one to go straight. So I get one to go in like this, on an angle like that, and then one can go straight there, and screw this in at 2 places in here. So I have something that comes down and goes forward and then up, and it screws into this plate here, and it comes off of here, and it's held tight by this piece, this flat piece of this, and that should keep that up, make it more rigid, and not allow it to stick out. I'm not sure why it's sticking out here. It looks like maybe the I need to adjust this. Maybe the there's tension between the motor shaft and the drive gear. It looks like it's being pushed back, sprung back, unless it's just the mass is bending the plastic, which, if that's the case, this would help a little bit at any rate. Okay, this moves, so I can't mount it to anything other than this table. And the only way I can mount it so far to this table is 2 screws, which aren't too big. If I mounted another plate here that hung down, it could hang down a little bit, but not too much. It would run into this stuff here, because this comes all the way up to here, this part. So it's gotta. So I can't do too much, but I can come out. At any rate, that's what I've been thinking about a couple of days now. but I'm running out of time. It's 4 o'clock. I have 1 hour and a half, so I'm not going to get a whole lot more done. But I do want to try to move this about and see what I can do. I'm getting better at figuring out where my machine is, where my part is, how I can set this up for the smoothest, best operation. And I think I'm going to try to take a cut at this and see what I do. Okay. All right. I'll get back to you later.